Start section 4.4, adding and subtracting rational expressions. We see that for the first problem, the denominators are the same. So this is the common denominator, right? When the denominators are the same, we're allowed to add and subtract in the numerator. So we have 5/7. If we look at the second problem, our denominators are also the same. So again, we are allowed to add in the numerator and denominator. And then you always want to look to see if you can simplify. Now we can factor out, divide out of 4 on top and bottom. So then 8 divided by 4 is 2, 12 divided by 4 is 3. So get same denominator, add or subtract up top, then see if you can factor anything out. Now, for number 3, the denominators aren't the same right now. There's a 10 and 30, right? So we need to have a common denominator. What we want to do is find our LCD, least common denominator. What I like to do is factor both denominators separately. So I would go 10 is 5 and 2, and 30 is 10 times 3, and 10 breaks down into 2 and 5. So least common denominator, it would be a 2, a 5, so I'm going to write denominator, LCD. We need a 2, because we need a 5, and we also need a 3. So our LCD would be 30. That's our least common denominator. Then you ask yourself, what do I need to do to make them both look like that, to make them both 30? Well, the right side's already 30, so we're good to go. We have to multiply the left side by 3 in the numerator and the denominator. So for the left fraction, we'd have 9 over 30 plus 7 over 30. Denominators are the same, so we can write 30. And up top, we have 9 plus 7, which gets us 16. After you combine, you have to ask yourself, can I factor anything out? Well, let's see. 16 and 30. I might first just start small, divide out 2. So 16 divided by 2 is 8. 30 divided by 2 is 15. 8 is divisible by 2, 4, and 8, but none of those factors go into 15 evenly. So 8 over 15 is simplified version. Now for number 4, our denominators are 7 and 5. So if we're looking for an LCD, if we take 7 and 5 and factor, we hit 7 and 5. So the common denominator needs to be a 5 and a 7, or 35. So then you ask yourself, once you find the LCD, what do I need to do to make both denominators look like that common denominator? So I need to multiply 5 by 7. I need to multiply the 7 by 5. So in the numerator for the left fraction, we have 5 times 5, or 25, over 5 times 7, or 35. For the right fraction, we have 7 times 3, which is 21, over 5 times 7, which is 35. We have same denominator, so now we're allowed to add the terms in the numerator. So 25 plus 21. So we have 46 over 35. Now, are there any factors that are in common? Let's see. 35 is divisible by 7 and 5, but 46 isn't by either of those. So that's our final answer, 46 over 35. So let's look at some of our next problems. So same process. When we're working with polynomial expressions, we need to find the least common denominator, ask ourselves, what do we need to do to make the denominators the same? And then once we combine, we see if we can simplify our final answer. And the screen always likes to move on me, so let's come on. Stop. So for this one, we first ask ourselves, what's the LCD? I like to factor both denominators first. So quantity x plus 4, nothing factors out. I'm going to put parentheses around it. X plus 4, nothing factors out, so I'm going to put parentheses around it. So the least common denominator is the quantity x plus 4. We don't need to do anything to either denominator because they're both the same. So I'm going to have everything over the quantity x plus 4. So up top we have x plus 5. Once you have your fraction, you see if you can factor out, right? Like if we had 2/10, we would say, oh, we can divide or factor out a 2. But here, once we factor up top, nothing comes out. So we put parentheses, factor on bottom, nothing comes out. So this is our simplified answer. Now if we said what are the domain restrictions, we would say the domain can be all values, but x cannot be -4 if you set your denominator equal to 0 and solve. Let's look at the next example. Now for the next one, we look at this and we see that the denominators aren't the same. Don't know why it always moves. So for this next one, we see that the denominators aren't the same. Sorry. So first step, you always want to find the least common denominator. You want to factor. So I'm going to factor the expression x squared plus 3x. And then over here, the other denominator is already factored, right? X times the quantity x plus 3. So we factor both. The left one, if I factor out an x, I'm left with x plus 3. So my least common denominator, I need at least an x. I need quantity x plus 3. So my LCD is x times x plus 3, or you could say x squared plus 3x. So I'm going to leave this one in factored form. Since both the denominators are the same, you can write it as x times x plus 3. Again, you want to leave it in factored form. Now I'm allowed to combine numerators. So I have the quantity 2x plus 1, and I'm going to do parentheses, plus the expression in the right numerator, 3x minus 8. I put it in parentheses because if this was subtraction, I would need to negate everything from the second set of parentheses. So now we have on top 2x plus 1 plus 3x minus 8 all over x times x plus 3. Before you simplify, you want to combine like terms in the numerator, make sure the top and bottom are factored, and cancel anything out that would cancel. So up top we have 3x, -8 and 1 is -7, over x times x plus 3. On top, nothing factors out. We throw parentheses around it. Nothing cancels in numerator and denominator. Now our domain would be all values, but x cannot be 0 or -3, right? If you set x to 0 and you set x plus 3 to 0 and solve, the two values that x couldn't be would be 0 and -3. Moving on to the next type of problem. So next, in example 2, when it says how can we find the least common multiple of the polynomials, we're going to do the same thing that we were just doing when we were trying to find least common denominator. You say least common multiple when we don't see this in a denominator, but if these expressions were in the denominator, some fraction, we would say find the LCD, least common denominator. So you're doing the same thing. So first we're going to factor both expressions. Now quantity x plus 2 is already factored. So it's x plus 2 times x plus 2. The quantity x squared plus 5x plus 6, we're looking for a combo that multiplies to a times c, or 6, that adds to b, or 5. That combination is 2 and 3. So we can write x plus 2 times x plus 3. Now for our least common multiple, or if we were looking with fractions, we would say least common denominator, we need to include x plus 2 we need to include another x plus 2 and we need to include an x plus 3. So x plus 2 times x plus 2 times x plus 3 is our least common multiple. We could also write this as the quantity x plus 2 squared because you have two of them being multiplied by each other times quantity x plus 3. These are the same. When we look at the next one, and we're also trying to find the least common multiple, we are going to factor both expressions first. So for the left expression, we can factor out an x. So then we'd be left with x squared minus 9. And then right in here, we can take difference of squares. So we would get x plus 3, x minus 3, and then x. If we do the center, so in the center, this is a trinomial. What factors multiply to negative 15, a times c that add to b. So we know it's some combo of 5 and 3. If they add to negative 2, the 5 has to be negative. So we'd have x minus 5 and x plus 3. Then for the last one, there's a GCF of x, and then we're left with x minus 5. So for this situation, our least common multiple would be, we need an x. I can circle that one. Then I'm going to circle x plus 3. Do any of the others have it? Yes. Okay. And then I see an x minus 3. Do any others have it? No. I have to write it over here. X minus 3. And then I see quantity x minus 5. Circle any others that have it. I need to add that quantity over here. So our least common multiple is x times x plus 3 times x minus 3 times quantity x minus 5. I'm going to stop here and continue in another video.